This lecture is on acid-base properties, specifically on concepts and trends of acids. Binary acids are acids containing hydrogen with another element. The two trends that will be discussed are electronegativity and bond strength. Acid strength increases across a period because an increase in electronegativity increases the acidity, because the more polarized the bond is between H and X, the more acidic the acid is. As evident in blue in period 2, in looking at CH4, NH3, H2O, and HF, the electronegativity increased from 2.5 for C to 4.0 for F, and simultaneously the pK has decreased from 50 to 60 for CH4 to 4.0 for HF due to this trend. Acid strength increases down a family because as the bond strength decreases between H and X, the bond length between atoms increases, and thus the tendency to attract to hold on to the hydrogen atom in its covalent bond decreases and likely convert to H plus ions. Here we are looking at the acids in group 7A, and notice the amount of energy needed to break the chemical bond decreases from 565 kJ for HF to 297 kilojoules for HI, because the weaker the bond, the stronger the acid. Another way to look at this is at looking at the stabilization of the charge, because the larger the ion is, the more stabilized the ion is. Since I minus has the largest ionic radii, it can stabilize the negative charge more than all others in this family. Oxy acids are acids containing hydrogen, oxygen, and another element. The two trends that will be discussed are inductive effect and electronegativity. Acid strength increases by an increase in O or oxygen atoms, because the more O atoms surrounding the central atom, since O atom is very electronegative, the tendency to attract electrons from the central atom, and thus weakening the OH bond in the acid. The example shown has H2SO4 or sulfuric acid with a K1 of about 10 to the 3 in comparison to H2SO3 with a K1 of 1.3 times 10 to the minus 2. The reason is because there exhibits resonance around the principal central atoms, in effect drawing the electron density away from the Y atom, but instead draws the electron density from the OH bond, weakening it, leading to the increase in acidity. In other words, the more O atoms around the central atom, the stronger the acid. Second, acid strength increases in a series of similar acids with the same number of O atoms, because the more electronegative the element Y in HXON, where N is 1 to 4, the weaker the OH bond is, and thus the more acidic the oxy acid is. In this example shown here between HOI, HBr, and HOCl, HOCl is the most acidic in this series because Cl is the most electronegative and draws the electron density towards it, and in effect weakens the OH bond in making it more acidic. Organic acids are acids that have the functional group RCOOH. The two trends that will be discussed are inductive effect and resonance. Acid strength increases by an increase on electronegativity of atoms on the carbon atom, because the more closer the electron withdrawing group is to the COH group, the more highly electronegative group draws electrons away from the OH bond, making the bond weaker and likely making the proton more deprotonated. In this example, we have CH3COH, or acetic acid, where it has a Ka equals 1.8 times 10 to the minus 5. CH2ClCOH, or chloroacetic acid, with a Ka equals 1.4 times 10 to the minus 3, and CCl3COOH, or trichloroacetic acid, with a Ka equaling 2.2 times 10 to the minus 1. As seen by its Ka values, the more electronegative the atom is, the more the atom will pull electron density away from the carbon's central atom, which in turn will pull electron density away from the oxygen in the OH bond, weakening the OH bond, thus making CCl3COH, or trichloroacetic acid, more acidic than either CH2ClCOH, or chloroacetic acid, and CH3COH, or acetic acid. Acid strength increases depending upon the relative strength of the conjugate base, because the more resin stabilized the conjugate base is, the stronger the acid. In this example, we have CH3CH2OH, or ethanol, with a conjugate base of CH3CH2O- and CH3COH, or acetic acid, with a conjugate base of CH3COO-. In this case, both anions have their negative charge on O, but it is more spread out over a larger area with acetic ion than with ethanoic ion due to resonance, thus making acetic acid the stronger acid. To end this lecture, here are a couple of review exercises for you to try. A, between formic acid and methanol, which one is more acidic? Why? B, based on their molecular structure, pick the stronger acid and explain your choice. 1, CF3COH, or C, Br3COH. 2, CH2Cl CH2COH, or CH3CHClCOH. 3, HBRO3, or HBRO. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.